No.
All right, today we are doing a lab. We are going to be making potassium trisoxalato ferrate 3 trihydrate. Okay? Sounds way more complicated than it is, but what we're going to do is we're going to be taking some iron chloride, iron 3 chloride to be specific, and it's a solution already, and it tells us that we're supposed to get 8 milliliters of it. Okay? 8 milliliters. Now, on the bottle, it tells you that the concentration is 0.40 grams per milliliter. So when you put this into your lab manual, at some point you need to make sure you, in your data, you put the concentration of the FeCl3, okay? Because that's real important. And then it says we're going to add some potassium oxalate. This was the missing ingredient before. But it's a monohydrate, and it says to put 12 grams. Now, in the equation that is on the sheet that I just gave to you, it says that it's going to be 3 K2C2O4s aqueous plus 3 H2Os. And that's going to then make the potassium trisoxalato ferrate. That's your trisoxalato ferrate 3, because it's in the +3, trihydrate. Okay? And then we're going to get some KCl as well as a byproduct. Now, ideally, this is going to be our solid. Okay? A couple of points to just pay attention to, and you might want to write this on this sheet or whatever. What's the first step in a stoichiometry? Well, first off, what type of stoichiometry? If we want to figure out how many grams of this we should make, our theoretical yield, what do I have to do to these things?
Make 5, which is the limiting reactant.
And how do I find the limiting reactant?
Convert it to moles.
Convert it to moles, right? Okay, so how do I convert this one to moles?
Use molarity, so you basically just multiply it, well.
8 times 0.4 is going to give you grams.
And you need to divide by the mole.
Divide by the molar mass to get the moles.
And there you just divide by the molar mass.
By the molar mass. Now here's the deal. In the equation, it's showing the water is broken apart because that's the way it's going to be once you put it into the solution. That's how it's going to be when you're at it. But when you weigh the 12 grams, that water is still part of it. Okay? So you have to include the water in the molar mass of the potassium oxalate. Okay? So when you're doing your calculations, not today, but when we do them, you just got to remember that we're weighing a solid. The water's part of the solid, but when you put it into the water breaks free and then just becomes part of the rest of the water. But when we're doing all of our moles and things, we have to make sure we include that. Now, we're also then going to measure 8 milliliters in a graduated cylinder. And I shouldn't have to go over this, but I'm going to. Slowly, slowly, slowly. Okay, so this is your graduated cylinder. Okay, can you guys see the 4, the 5, the 6? Okay, so what's the smallest? This is 5 milliliters, 6 milliliters. So each line is, well, just in decimal points in terms of milliliters. 0.1, right? So this is 5.1, 5.2, 5.3, 5.4, 5.5, right? So how many places do we measure this to? 2 decimal places, 1 pass. If it's on the line, it's a 0. Now these lines are pretty close to one another, so if it's on the line, it's a 0. If it's in between the lines, we go to the 5. Okay? So we need to make sure we always measure to the proper degree of accuracy when we're measuring out. So you're going to measure, it says 8 milliliters. You don't have to have exactly 8, you just need to know exactly how many you have. Read it exactly off your graduated cylinder. You don't have to have exactly 12 grams of the potassium oxalate monohydrate, you just need to know exactly how much you have. Okay, just about 12. All right? Now, lastly, when you're going in here, you're going to have to heat up the water. You're going to put it in 20 milliliters of water. You're going to have to heat up the water to get the potassium oxalate to dissolve. You're going to heat it, you have a thermometer, you're going to heat it to about 80 degrees. Do not let it boil. Do not let it boil. Turn the heat off when it gets to 80 and keep stirring, and I'll come around and help you make sure that it all gets dissolved in things. But don't let it boil. Okay? Once it's hot, you can use those orange hot hands and take it off the fire, but then while it's hot, go ahead and add in your 8 milliliters. So you might want to go, they kind of messed this up before. Get the 8 milliliters first. So then once it's dissolved, you can go do that, because some of them in first period, by the time that they went and got the 8 milliliters and came back, it had cooled off and it started solidifying again, coming out of solution. So get your 8 milliliters first. Have that ready to go. Once it's all dissolved, just mix it while it's hot. We're going to stir it. Now, what's going to happen is this is going to be in your solution to start with. It's going to be well, I don't want to give the color away. It's going to be, it probably tells you. Green, okay? It's going to be a green solution, but we need that to precipitate out. And what we're going to find is that we have a solubility curve when we look at temperature versus grams dissolved, okay? Our curve is going to look something like that. It's going to be pretty steep. To where at the 80 degrees, all of it's going to be dissolved. But we're going to put it in an ice bath and cool it down and try to get as little dissolved as possible, get as much to precipitate out as possible. We're not going to be able to get it all out because potassium compounds are still soluble somewhat. This right here is what we call a complex ion. It's a Fe3 plus ion with the oxalate ion. Okay? That's why we get the complicated name potassium trisoxalato ferrate 3 trihydrate. Okay? So that's a complex ion. They're kind of unique. So we're going to go through, heat up, dissolve it, add our 8 milliliters, stir it, put it into an ice bath, and then collect, and then it's going to solidify. Then we're going to filter it. We're going to use vacuum filtration. I'll show you how that works in the lab. Okay? Rather than just letting gravity, it'll just suck it through. It goes way faster. Then we're going to try to purify it through the process called recrystallization. Now when we go into the lab, you're going to have 15 minutes when it's just sitting in the ice bath. On the back side of that paper, there's a whole section on recrystallization and how things get purified due to recrystallization. You get to read that during that 15 minutes it's in the ice bath. Okay, and then we'll talk about it. All right, but we're going to try to basically purify it. It's going to be simple. We're going to redissolve our crystals in 15 milliliters of water, heat them up until they dissolve, and then do the exact same thing. All right? So, goggles and aprons. Now, I can't remember where your goggles are, which one bin it's in, but we need to find your goggles. Okay? Everybody almost is dressed appropriately. Okay? And then we'll go to the lab.
Wait, do we have our own goggles?
Yeah, she wasn't here when you signed